Dear students, today we will discuss another important topic in revision. In last class we are discussing about the image formation in convex mirror, and we have also discussed the uses of concave and convex mirror. Today we will discuss a very important formula, that is mirror formula. Last class we have also discussed sign convention, that is a very important topic. So mirror formula is basically the relationship between object distance, image distance and focal length of a spherical mirror, and this can be represented as 1 by V plus 1 by U is equal to 1 by F, where the symbols have usual meaning. As you know, V is equal to image distance, U represents object distance, and F is focal length of the spherical mirror. We are writing spherical mirror because the formula is true for concave as well as convex mirror. So what is mirror formula? So mirror formula is simply a relationship between image distance, object distance and focal length of a spherical mirror. Now another important thing is magnification. Magnification. So symbol for magnification is small m, and we can say that magnification is simply a comparison. We are comparing the height of the image with the height of the object in magnification. So it is simply the ratio of height of the image to the height of the object. So magnification is equal to height of the image by height of the object, and symbolically you can also represent it. M is equal to, you can write either HI or for image, or H dash, or for height of the object you can write HO or H, like this. Isn't it? Now this formula is also related with image distance and object distance. Magnification is also related with image distance and object distance, and it can be expressed as m is equal to minus v by u. V is image distance and u is object distance. Now magnification is another important term. Sometimes magnification is negative. If you will get sign, minus sign in magnification. So if m is negative, if m is negative, it means that image is real and inverted. Must remember these points. If m is positive, it means there is a plus sign in magnification. It shows that image is above the principal axis, so image is virtual and period. Another important thing that if m or you can say magnification is 1, if suppose magnification is given here, so if magnification is 1, it means the size of image is equal to size of object. If magnification is less than 1, it means size of image is less than size of object. Similarly, if magnification is greater than 1, its meaning is size of image is greater than size of object. So you must remember these points. That what is the significance of various values of m. If magnification is equal to 1, then image size and object size are equal. If magnification is less than 1, it means size of image is less than size of object, and if magnification is greater than 1, then size of image is greater than size of object. So all these things which I have written today, these are very important for solving numerical problems. And in the last class, the sign convention which I have discussed. If you make a clear concept of these things, then you are able to solve any numericals related with spherical mirrors. The clear concept of sign convention, what is mirror formula, what is magnification, what is the meaning of this sign, how to calculate magnification, these two formula. So these formulas are very important. You must learn it. Here I have given a slash sign because in some book height of the image is represented by hi, or in some book they represent it by h dash. Now we will solve some of the board questions. So I am reading a question. I am not going to write it. You just listen the question and then I am going to solve. The question is, in 2017 this question was, an object 4 centimeter in height is placed at 15 centimeter in front of a concave mirror of focal length 10 centimeter. At what distance from the mirror should a screen be placed to obtain a sharp image of the object? Calculate the height of the image. So you have to calculate two things. First, you will read the question carefully or listen it and write down the given things. So as it is given, an object 4 centimeter in height. An object 4 centimeter in height, so h is given 4 centimeter. You can also write ho. Is placed at 15 centimeter in front of a concave mirror. So object is placed at a distance of 15 centimeter, and just remember it, in sign convention we have discussed that object distance is always negative whether mirror is concave or convex. So we are writing u is equal to not simply 15, but we are writing u is equal to minus 15 centimeter. Then its focal length is also given 10 centimeter. So it is a concave mirror 10 centimeter, but before writing 10 centimeter you think it will be positive or negative. So suppose this is a concave mirror, so and this is principal axis, parallel rays of light will fall on it, so the rays will meet at a point after reflection. So this point is F, this point is P. The distance between these 2 points is focal length, and now you can see this is towards left of the pole or towards right of the pole. Obviously towards left, so focal length is also negative for concave mirror. That's why you have to write minus 10. If you will write simply 10, your answer will be wrong. Sign conventions are very important. Must take care of it whenever you are writing the numerical value. Must check their sign. Then at what distance from the mirror should a screen be placed to obtain a sharp image? It means where image will be formed, where we should place a screen. It means you have to calculate V. Then calculate the height of the image. It means you have to also calculate H dash. Now use mirror formula. So we know that 1 by V plus 1 by U is equal to 1 by F. We have to calculate V. We don't know the value of V, is not given in the question. So we are writing simply 1 by V plus 1 by U. U is minus 15 and 1 by F, and F is minus 10. So this can be written as 1 by V. We will plus minus 1 by 15 is equal to minus 1 by 10. Now take 1 by V this side, transpose this term towards right, so it will be plus 1 by 15. Now take the LCM. So LCM will be 30. So it will be minus 3 plus 2. So it will be minus 1 by 30. Therefore, G is equal to minus 30 centimeter. It means if you will place a screen at distance of 30 centimeter from the pole, obviously towards left side, because we are getting minus 30, then a sharp image will be formed. So the first thing we have calculated, first we have to calculate B, and now we will calculate H dash. So to calculate H dash, now we have done that magnification is equal to minus V by U. We have also learned that M is equal to H dash by H. So if we will combine these two equations, we can write H dash by H is equal to minus V by U. So this is also an important relationship, and we are going to use this relationship here. So we can write H dash by H is equal to minus V by U. H dash we have to calculate. H is 4, this is minus, V is minus 30, and U is how much? Minus 15. So this minus cancel. This is 15 to the 30, and then H dash is equal to minus 2. Cross multiplication, minus 2 into 4, it will be minus 8 centimeter. So minus 8 centimeter, it means if there is minus sign, it means image is below the principal axis, and below the principal axis, it means image is real and inverted. So I think this question is clear to you. Now we will solve another question. I am taking a question from 2015 now. The question is, to construct a ray diagram, we use two rays of light which are so chosen that it is easy to determine their directions after reflection from the mirror. Choose these rays and state the path of these rays after reflection from a concave mirror. Use these rays to find the nature and position of image of an object placed at a distance of 15 cm from a concave mirror of focal length 10 cm. So, what are the given things? Object is placed, or I will write this question. Okay, writing this question, and then we will solve. To construct a ray diagram we use two rays of light which are so chosen that it is easy to determine their direction. Directions after reflection. From a concave mirror. Use these rays to find the nature and position of the image of an object placed at a distance of 15 centimeters from a concave mirror of focal length 10 centimeters. So let us read the question carefully. Yes, it is true that whenever we have to draw a ray diagram, we are taking two light rays only for simplicity, and these rays are chosen in this way so that after reflection we can get an image easily, and use these rays to find the nature and position of the image of an object placed at a distance of 15 centimeters from a concave mirror of focal length 10 centimeters. So given things are object distance and the position. Object distance is minus 15 centimeters and focal length of concave mirror is minus 10 centimeters. So if you will think over it, so there is a concave mirror, suppose. The center of reflecting surface is pole. Draw a horizontal line which passes through pole. Then mark the point F and C. Isn't it? So, according to question, focal length is 10 centimeters and object distance is 15. It means somewhere here. So you can guess the object is placed between C and F, isn't it? So object is placed between C and F. So if the object is between C and F, you will draw a ray diagram. So first we will take a ray of light which is parallel to principal axis. So after reflection, this ray will pass through focus. Then we will take another ray which passes through focus. You can also take through center of the ray, but for simplicity we are taking it from principal focus of the ray. So if you will take this ray, it will, after reflection, it becomes parallel to principal axis and they are meeting at this point. So you will get a real inverted image of the object. So this is the case. So you will write first the two rays. The first ray will be, first ray is parallel to principal axis with, after reflection, passes through focus, and the second ray passes through F, and after reflection becomes parallel to principal axis. So we have discussed the two rays which we have taken to draw the ray diagram, isn't it? And from a diagram we can say that the nature of the image, or you can use mirror formula to calculate V. So 1 by V plus 1 by U is equal to 1 by F. So 1 by V plus U is minus 15 and F is again minus 10. So similar type of question. So it will be minus 1 by 10 plus 1 by 15. So 1 by V is equal to, you will get minus 1 by 30. So V is equal to minus 30 centimeter. So this distance is 30 centimeter. So what we can say about the nature and position of image? So V represents position. So image will be formed at a distance of 30 centimeter from the mirror, and nature is real inverted. Nature is real and inverted. You can also mark object and image. A dash B dash is the image. So if you will answer in this way, you will get the full marks, isn't it? I think the question and as well as its answer is clear to you, how I have discussed it.